Good afternoon, everyone. I hope you've all had a nice lunch and that you're suitably refreshed. And we'll move on with the second technical session in today's seminar. The second session is entitled Indian Experiences in Geospatial Standards Development and Conformity Assessment. I'm really looking forward to this session because it will showcase where India is in terms of its standards development. And I'm looking forward to seeing some of this really good work that's been created. So I'd like to thank the BIS for putting together this excellent list of local speakers. Granted that some of you may not all come from New Delhi, but it's good to see such a strong lineup of speakers. So if I could invite the first three speakers to the stage, please. So that's Sonami Bora, Dr. Reddy, and Vijay Kumar. Can you come to the stage? Okay, so we've got these three speakers, and then we've got a further three to end session 2, and then the final part of the day we've got a panel discussion. So our first speaker is Sonami Bora. He's from the Department of Land Resources in the Ministry of Rural Development. And he's going to speak to us today standards implementation in the DILRM. Sorry. Just check. Mike, is it ready here? Where is it? Maybe this one? Yes, this one. Yep. Yeah, I think so. This one. I think this is the one.
This is the one.
Yeah, I think so.
They will switch on to the PPT mode.
Yeah.
Or it's in a PDF mode. Okay.
No.
It's a PDF.
Just 1 minute.
It's a PDF one.
The other one should be PPT. Yes.
It's done.
It's done?
Yes, done. PPT mode that is. Yes, sir.
Yeah, I think this.
Good afternoon, everyone. I must compliment BIS and ISO for this wonderful event, where all the stakeholders, including Government of India and other agencies, have been put into one place. And I'm told that in the morning sessions, a lot of deliberations already happened. A lot of brainstorming into the issues, different models in India and around the world have been already talked about. I think all the participants are going to be immensely benefited from this brainstorming. And I'm also told that this is live, so everything is put in the digital footprint. So one can again go back and see whatever, if one has missed something. And kindly excuse me because I could not attend in the morning session because of many preoccupations in the department and the ministry. So I'm really happy to be here this afternoon. And right after lunch, I think everybody must be feeling very heavy. So I'm keeping it very light. So some of the initiatives we have taken already initiated in India. So we'll talk about and how Government of India from a pan-India perspective is actually trying to support the states and union territories as far as the standardization of different aspects of textual as well as spatial data is concerned. So since we have a lot of friends coming from outside India, so I think for their benefit, I would like to give a snapshot that how actually India looks like and what is the composition. So here you can see that we are already number one in population. And if you can see our GDP, we are fast moving very rapidly into the base of 3-4 economies in the world. And if you look at our structure, we are actually kind of federal system where we have around 28 states and 8 union territories directly governed from the central government. So this is the composition. So I mean, many friends, I mean, I know they are all aware of, but still they may think that India may be a very composite kind of unit where, standardization may be very easy, sometimes, but it is easier said than done. And it is a huge challenge as far as our federal system is concerned, where we have to persuade, constantly follow up with the states and other stakeholders. And there also you will see that within the state also, there is huge diversity, prevailing in the states. This is our administrative hierarchy. So Government of India at the top, then we have the state governments, UTs, then we also have administrative boundaries called divisions. Mostly these are revenue divisions within the states. Then you have districts. Within the district also we have some blocks. Then local bodies could be urban bodies or gram panchayats to say the villages. So villages is the lowest unit in the entire hierarchy. So the department does many things apart from digitizing the land records or the registration process, mutation process. So we have plethora of mandate as per the business rules of Government of India. You can see that right from land related, all kinds of works are actually allocated to our department. We just don't do digitization of land records or registration process. We also administer various acts. Apart from that, we also have the mandate for land use, land tenure. You can, think of anything related to land, and that is that everything actually falls within the domain of our department. So I'm not going to speak on this, that why it is so significant, why it is so important to have land digitization, why and how it is going to benefit. But here you can see that there is a huge diversity prevailing in the country, and there is a huge need as well, where a single source of authentic information is readily available for the common citizen as well as for the government. Here I'd like to emphasize that we have 3 lists for subjects. One is the union list, then we have a state list, then we have a concurrent list where both the union government as well as the state governments are empowered to enact laws. So here you can see that land and its management actually falls within the domain of state governments. So the union government here comes in a very supportive kind of a role. Than to say that where we see that certain standardization actually takes place in all the states, since there is a huge diversity in various aspects. So historical legacy, if you can look at, we have a colonial past. So if you go beyond the colonial past, so still there were a lot many monarchies and a lot many conglomerations where there was asymmetrical, land record keeping system, methodologies and ownership, so and so forth. During the British time also, whatever they tried to do as far as survey is concerned, or keeping the records, so that was mostly aimed at collection of taxes. After independence, lot of initiatives taken place. There was a huge demand for land reforms as well, but soon it was felt that land reforms can come when your land records are in order. So thereafter, from 80s, the initiative slowly moved up, where the land administration were actually focused. But as I have already mentioned that within our federal system, the land and its issues are so sensitive at times that they need to be answered very carefully and have to be brought in all these reforms or all these initiatives cautiously. So slowly it kept on, the Government of India kept on working on this. 2008, that is a watershed time when there was a centrally sponsored scheme, national scheme was initiated for land records digitization. Thereafter, in 2016, it was made a central sector scheme where now we provide 100% funding to the states and UTs for implementing different components of the land digitization scheme. So as we move on from 75th year of independence, so we have a very futuristic plans for India, where second generation reforms and third generation reforms are actually now we are moving on. So here you can see that the journey itself, we have already come across various milestones. Used to be manual. From there, we moved to computerization, digitization. At the same time, you can see that the cadastral maps and field measurement books prevailing in some parts of the country were actually digitized, as well as they were all linked with the record of rights. Then this land registration part also. So we tried to strengthen that part of the important process, because from registration, again, it comes for the mutation part, which again gives the titling. So this is also equally important for the land registration process. So here you can also see that these all initiatives and components, while doing standalone, but at the same time, they have been all linked. All systems have been linked to one another. Then the final focus came in, that is the georeferencing. We thought that this locational information and data is actually extremely important, not for the citizen, but for the government as well. So now whole focus is georeferencing, where we are slowly moving to GIS ready land governance. As it must have been already talked today, this new geospatial policy which came in last year. So now there is a huge focus on the creation and sharing, generating. So all these data, and in a way, India has now opened actually. So long as all these data were stored mostly in a very standalone kind of situation, but where now India has actually liberalized that whatever we have created, suppose as a department, whatever data we have created, now it is open for others to optimize on that. And whatever data other agencies, other stakeholders within the government are creating, so those are also now being shared with each other. So there is a whole of government approach, which is, I think, a very momentous milestone in the journey of India itself. So I'll just briefly talk about the scheme which we have been spearheading in India. Yes. So this is the scheme I have already talked about. Here you can see this is mission. I'm not going into detail about the objectives I have already talked about. Here I would like to emphasize that you see the enormous task we have already achieved. More than 31.98 crores of record of rights have been now computerized, which means that almost 95% of the villages in India have been now computerized. We have some issues, especially with the northeast part of India, where we have community ownership and the details are not being shared with the government. But there also we have now have a big breakthrough, and all these autonomous district councils are coming forward for the project. So I'm just, because I think this PPT will be shared with all. So if you should have any queries or any remarks or any suggestions, so you can always write to us. So here you can see that the huge achievement actually been already done in India. Second, here I'll like to talk about this Bhu Aadhaar, we call it in local language, which is a unique land parcel identification number. And this is again ECMA and OGC standard compliant effort, where each land parcel of the country is being assigned a unique number, which is based on the geo-reference, geo-coordinates of the vertices of the land parcel. So I can tell you, as I stand here today, that more than 14 crores of land parcels across the country have been now assigned this unique ID based on the geo coordinates. So 27 states have already adopted this practice, and we are hopeful that another 2 years' time we'll be able to complete the rollout of this new initiative. So benefits, the enormous benefits, here you can see. And for regular parcel of the land, whether it is irregular land parcel, whether it is embedded plots, so everywhere you can create this land parcel. This is an example from Madhya Pradesh, where you can see that the record of rights is now embedded with the first column itself is the Alpine number. So now there is a legal backing for this number. So we are slowly doing away with the old survey numbers. Of course, in the legacy data, we'll keep in the storage, but this is the new number through which interoperability of different systems and different services will be actually taken care in India. We are also trying to standardize the survey, resurvey methodologies. You can see here also. E-registration, one nation, one software in the land registration also we are trying to standardize. We have a generic software which is being now adopted by 18 states and UTs. Another 12 are also conforming to our basic modules, and they are also sharing their data as well. Transliteration, because India is a diverse country, so we have so many languages. The Indian Constitution itself recognizes 22 languages. Most of these record of rights or the land records are in the local language. So we have taken up the phase one is the transliteration of the record of rights. The second phase is the translation. All the documents, etc., will be translated into English, Hindi, and rest of the 21 Indian languages. Also, we are linking with the civil courts. So all courts, all the disputes, we are hopeful that with this giving access of the land records with the civil courts, the civil court cases disposal will drastically reduce. So these are some of the initiatives, and there is a huge scope for collaboration with, I know I'm running out of time. We look forward that we have a very meaningful collaboration with all the agencies, especially we are going to be an active partner with OGC very soon. And we are hopeful that with ISO, FIZ will work together. And in LADM also, we are interested now. And we know that there are a lot of issues as far as the Indian conditions are concerned. But there is a readiness, as I have already explained, whether it is the measurement, whether it is the standardization of the record of rights, whether it is the unique land parcel. So we have already started various initiatives. So there is a readiness. Of course, there are purpose and goals, there are issues, but I think in due collaboration and due course of time, we can come out with solutions, and we can have a customized LADM for India. And maybe soon we can have a stakeholder brainstorming with all the states and UTs where we can create a model or which can be adopted by all the states, maybe in a particular block or few villages or few districts, and thereafter it can be rolled out. I think with these words, I'm not going into detail of the issues, and challenges. This is the way forward, which we are looking at DOLR as of now. And I thank the organizer for this opportunity to present a few of the initiatives we have taken at DOLR for land governance and standardization. Thank you very much.
Thank you very much. I appreciate that 15 minutes isn't a very long time to talk about all your activities, but there's a couple of things that struck me really. The first is your use of unique parcel identifiers. That's something that we've already doing in the UK. And I used to think that I used to deal with a lot of big data with a UK data set, but nothing on the scale that you have to deal with in India. So that's really quite admirable work to reach the point that you are now, and that you are considering. I think blockchain on the screen there as something going forward to help with your property transactions. So brilliant. Thank you very much indeed. That was a whistle stop tour. So thank you. Our next speaker is Dr. Reddy. And he comes from the National Bureau of Soil Survey and Land Use Planning. And he's going to talk to us about soils, geology, and forestry. Thank you. Yeah.
Thank you, Chair, and good afternoon to the Galaxy of experts joining here, and good morning and good evening those who are joined online. In fact, I am discussing a brief on data content standards on geology, soil, and forest. If you look the continuum of these three domains, the geology is subsurface part, and over the geology we have a soil, and on soil we have a forest. So I am discussing in that sequence. First, I may touch upon the geology. In fact, actually, this is a national effort and developing the national standards in Indian context. And here, actually, the domain institutes are involved, of three domain institutes, as well as the National Spatial Data Infrastructure (NSDI), and the working group on the data content standards, as well as LITD 2022, a panel 2 working on a data content standards. So this is and of course the IT domain, the IT inputs are given by from IIT Mumbai. This is the GIS lab, IIT Mumbai. So this is a combination of the experts from different organizations in the Indian context, and brought out these drafts of these three domain areas. So if you look at the the core objective of this, the content standards of these important domains is basically to provide a common definition of standards, standardized attributes of geospatial information on surface geology, soil, and forest, to facilitate the effective use and enhance the data visibility and dissemination of the standardized geospatial information to the users. And of course, to resolve the disturbances which are having within the domain and across the domain, but to use the data sets of the various organizations and agencies to minimize the duplication within and among the data sets. And of course, to provide the guidance and direction for geospatial professionals on standards and standardized attributes and definitions to improve the standards in data acquisition and management. And of course, this is actually, as I told you, it is a participatory involvement approach. And we had a wide consultation with the stakeholders of all the 3 domain areas over the course of time. I briefly discuss about the data content standards on surface geology, which is basically, core organization is from Geological Survey of India, which is a Ministry of Mines, Government of India, which are, involved in this developing the standards in collaboration with other organizations. Of course, the working group of the NSDI, where actually 17 organizations are associated with that. The core aim of this surface geological, the standards of surface geology is to actually standardize the process of surface geology was carried out through wider consultation with the stakeholders within GSI and other associated organizations. And the objective in developing these national standards for geological mapping, and of course map symbols, colors, and patterns, how we are actually mapping and how we are generating the database. And it is also provide the common definitions for various geological information and parameters, in the database which is generated by the GSI. The surface geology is actually, it is covered on 1:50,000 scale soil information, geology information generated by GSI. And of course, these DCS, that is a data content standard geology, will also have a significant helps to follow the uniformity across the organizations in data acquisition and data management, as well as data dissemination. If you look at this conceptual model of this whole exercise on data content standards and geology, it is basically linking with the surface geological information and all the associated parameters you can see here. Because see, like geological structures, if we again structures, we have a folds, faults, and shear zones and dikes, and various attributes which are associated and which are linked properly to provide the comprehensive information on surface geology, including fossil fuels and mineral resources, even archaeological sites, imported archaeological sites as well. If you look at the details of this data content standards developed by the core GIS organization, each parameter was very precisely described and decoded, in the document. Once we see the document, you can see the more detail of each parameters, how we define in standard way, so that all the users, all the stakeholders can use it for their data generation. Similarly, if you see like a small one parameters like a fold, how we have defined different types of fold and what do you mean by each fold of the geological formations, we can see the details like this. And this indicates, or this diagram shows the entire this data content standards on surface geology, how each parameter is linked and how they are associated to the main surface geology on the top, and each parameters how it is associated with the other what you can say like hierarchical level in the database. And these are all actually significantly used in the data generation, and it's a Bhukosh portal is there from GSI. There already most of these standards are implementing and they are disseminating the information. And of course, it is always in a continuation process. So we are actually using, refining the existing data standards in a portal to disseminate the standardized information to the global community. Coming to the second part of this soil, this is on the data content standard on soil, which was basically in the core organization is involved. This National Bureau of Soil Survey and Land Use Planning, located in Nagpur. And this document, which is already submitted to for the further processing. Here is actually all the soil information what we generate normally. So we have actually standardized and listed all the parameters, and these standards will significantly help to store, retrieve, and manage the spatial and non-spatial information of the soil more effectively when we are going for the geospatial data management and geospatial data modeling. If you look at the broader perspective of the soil content standards, which are basically categorized into 4 categories like soil site parameters, soil morphological properties, soil physical properties, and soil chemical parameters. So we can see the bracket, how many parameters, sub-parameters are there in each, the main category. If you look at the one parameter, say for example, soil site parameters, you can see like drainage. What are the classes normally we follow in standard format of this? How you define the surface, so it means drainage. So we have standardized classes and what type of data type and how we describe each class. When you say the very poor drain soil, how you describe it in standard way. So those things we have given in the document. And similarly, physical parameters, if you see, for example, soil depth, what are the standard depths we follow normally? What is the range? When you say the shallow soils, so what we have to follow across, the national standards. So like 0 to 10 meter, we call it extremely shallow soil. Like that, we have a different depths up to 150 centimeter, even more than 150 centimeter, very deep. So these are the, the standardized parameters we have defined. Similarly, chemical parameters, there are a host of chemical parameters. Just I'm described the soil pH. So that once we have this type of data set, so that whoever is generating the soil information across Indian context, so that we can follow the same standards and that database can be put on a common platform for the user's perspective, and we can disseminate that information to the users. If you look at the conceptual model, which is, so here actually significantly, contributed by the IIT Mumbai in developing this IT support, in developing these conceptual models of 3 domains. Here, if you see, the soil mapping unit is a core part of the soil data content standards. So all the attributes, like whether it's say like soil site, physical, chemical, and morphological properties, which are directly associated with the soil mapping unit. When I say the soil mapping unit, if I click the soil mapping unit, or if I query the through soil mapping unit, I can get all the information of this, or the related soil property information. Again, we have a different properties on the morphological, physical, and chemical. So if you look at this code list, how we have prepared for across the 3 domains, when I say the soil site characteristics, so there are the huge number of, the different code list, and each code list we have a classes, how we are defining that particular code list. So these are all actually linked in the model. Similarly, morphological properties. Similarly, we have a physical properties. And similarly, we have a, soil chemical properties, because all the properties which may not require the code list, which some of the properties which have a what you can say like absolute values. So for example, soil organic carbon, if you don't have a standard classes, so we are giving the, out of the code list, but those we can define in absolute values. Similarly, if you look at this overall UML diagram of the soil, so all the parameters which are associated, either it is in morphological and physical and chemical, they're all linked to the, say like your soil mapping unit. On the left side, on the top, you see this is the soil mapping unit, and all the morphological, physical, chemical properties, including the soil taxonomy of different levels of soil taxonomy, like order, suborder, grade group, subgroups, soil series, all are associated with the soil mapping unit in the model. So this way, actually, we have standardized the information. And we also implementing, as I told in the geological case, in the soil domain also, we are actually portal. We are majority of these standards, actually, we are implementing and developing the soil portal for dissemination. We are also developing the interoperable platforms. So here, actually, 3 portals already linked, and 3 portals can talk each other, the databases in interoperable mode. The remaining part is next to how to develop the applications by using this information. That is actually the next challenge. If you look at the next third data content standard, that is on forest, which is basically developed by the Forest of India. Again, it is under the Ministry of Environment and Forest and Climate Change, Government of India. They are significantly, they are the core domain areas, domain institute in developing this forest information. And here, actually, this FSI, Forest of India, basically involved in as a nodal and the premier organization in India, is involved in forest cover and forest type mapping across India at the biennial basis. Every 2 years, they are developing this information and disseminating to the users. And of course, many other associated parameters also they are mapping while doing the forest cover mapping, forest cover and forest type mapping. So these are some of these recent updates on forest cover and forest type mapping of India. So you can see the distribution, how they are, and what are the dynamics they are mapping by using the satellite and of course the legacy data which they have developed over a period of time. So this is a more precisely mapping, and these databases extensively using by various stakeholders and users across India and outside.
So if you look at this forest cover mapping, see, these are the different classes and how we have coded in short name, whether data type, what type of data type we have, and the unit of measures, then description, as we mentioned in other domains. Similarly, here also, each parameter was clearly defined and was standard definitions were given. Similarly, we also given here this sample of forest type, how this hierarchically related, how we can say like a major group and subgroup and forest type, and what is the description of each class. So, and the code, corresponding code also is defined in the document. So this way, all the parameters were standardized and coded in the document. Here, if you see the UML part, this is actually explained again as we've seen in the other two cases. Here also it explained how the databases and how the structured in the model, the forest type and forest cover, how we have related and how they are associated each other. And we also followed some of the standards, existing standards in developing this data content standard like ISO 19103, ISO 19107. These are the standards which are available. We have also followed in developing, the content standards for forest. So these are the important, the UML diagram for this forest. Here again, explain how this forest cover and forest type was related and what are the associate parameters, whether it is a one-to-one relationship or one-to-many relationships. We can see in the model how they are associated in the data structure. So this is a UML part of this forest. So you can see the each parameters and their associated parameters, how they are linked, and how we have organized in the document to define this forest cover and forest type database. If you look at this, the importance of these documents, which are the submitted drafts, which are these three domain areas of this data content and significantly helps for uniform data acquisition, maintenance, and interoperability in the coming years, because these are the major challenges when the many organizations are involved in the generation of the data. So the acquisition and maintenance is very, very important. So I think these standards will significantly help. It also helps to strengthen the geospatial infrastructure in the Indian context to assimilate and dissemination of the standardized information to the users, so that users can use that standard information for various applications. And we can also use this information to develop the theme-based applications through service APIs, and of course through geoportals for dissemination to the users, because the next level of next course of this implementation is the developing the APIs for various applications. And we can also develop the interoperability, that is again very important challenge, and reusable services through service APIs, so that users can use across the domains for various applications. And we are also trying to develop this cloud computing capabilities and data analytics once we have these standards in place, so that we can go to the next level of analysis. And these standards significantly helps to develop the cross-domain and domain-based applications, and to enhance the economic value of these resources, the valuable resources at the national level. And it directly contribute to this economy of the country. So that way, actually, we are contributing through developing the standards across these domains. Of course, other domains are coming up. So this is the in brief of these data content standards on surface geology, soil, and forest. So I'll stop it here, and thank you very much. Thank you very much.
That's a really fantastic description. You can what you can see from your presentation there is just the complexity that when you start to put together a data content type standard, and the interaction that you've got in the way that you've structured your data between geology, soils, and forestry. I think that was great. I also like the your conclusion slide. I like the word interoperability in there, because I mentioned that this morning, to make your data interoperable. But you see the benefits for both your customers, and then more importantly, for future development. I think that is definitely where standards play their part. Okay, our next speaker is from industry, and that's Vijay Kumar, and he's come from Esri, and he's come to talk to us about opportunities and challenges in standards implementation. Vijay.
Thank you, Adam.
Thank you.
Yes. Thank you, Alan. It is really pleasure to be part of this conference, this workshop, and thank you BIS and ISO for inviting me to share my thoughts and experiences. So in the morning, I got an opportunity to attend sessions from various speakers. I heard Scott and Chris and Ellen and Don and a few more people. It is really great knowledge sharing, in fact, and very motivating, content from everyone. And I think one thing is I really appreciate that working in a standard creation is not an easy task. It needs a lot of patience and passion. So probably we should have a big round of applause for everyone sitting here who are really passionate about the standards. It's a great work, in fact, and which all of you are contributing in this domain globally. So here today, I would like to share my thoughts around importance and experience with geospatial standards. I'm Vijay Kumar, CTO at ESRI India. So we at ESRI, we carry open vision. We believe that sharing, collaboration, and interoperability are crucial to addressing today's challenges with urgency. And I think all of us are agreed, and that's why we are here, and which is a very, very important, aspects. Just to share our experience, how we actually look at it across ArcGIS, ecosystem. So if you see, standards are, we categorize this, let's say you have domain data standard models, you have metadata, you have web services and APIs, you have security domain, encodings and catalog and search, accessibility. So the cross-system workflows actually across. Standards are not just around data only, but I think across. And what we realized, if you see the bottom part of it, every part of the life cycle or implementation or life cycle also today, when you produce or publish, collaborate, share, use and reuse, and interconnect or collaborate, I think every part of the life cycle, these standards plays very, very important role. So that's why I think success of any system implementation across the world, I think, is governed by these standards practices everywhere. So success is integrated and holistic. When you follow these standards and this interoperability and this kind of thought process, success is integrated, which is connecting organizations. If you see open systems, solutions, supporting services, engagements, data and technology, and governance part is also part of it. Capacity planning is also part of it. So in fact, if we follow standards, right, capacity planning is also governed actually in an effective manner, which is an integral part of the success story always. So in fact, every geospatial database infrastructure everywhere in the world, I think without standards, it can't really work and be successful. And this is our experience also in multiple, many large implementation across the world and in India as well. So it's kind of a system pattern. When you start from, let's say, regional planning or foundation data initiatives, or you have whole of government collaborations, multi-level collaborations, right? This all makes actually quite effective when we follow standards in implementations and in product and in projects, which is actually a kind of experience with everyone, all of us. And that's why this becomes very important and key aspects when we integrate and develop products and solutions. So connecting community, how worldwide we see organizations that need to share open and secure decision-ready data everywhere. I mean, data can be open, but it need to be secured also, right? So that engagement of community can happen across the stakeholder. So standards plays very important role in those. So making data open as well as secured, right? That's actually everybody would like to have. So people are interested in connecting and collaborating in a system of systems to support knowledge, understanding, and action on various key decision-making aspects, which is actually again standards play major role. I would like to share a couple of examples and experience, how actually large implementations actually were successful when we use standards in the back, entirely in the product as well as in implementation also. So you see, this is geo-enabling sustainable development. So we created this framework, which is primarily in an interconnected system of systems for the SDGs, where multiple countries are collaborating, right? It's a hub network. It's the SDG hub network where multiple departments, multiple ministries, multiple countries are collaborating and bringing it to common set of standards. It's a great experience, in fact. When you talk about influencing new adoption and conversations, the work we are doing on standards interoperability is helping to drive conversations and new adopting of these integrated patterns. I think standard plays that role, critical role there also. When we start the conversation and when we want to actually solve the business challenge and objectives. So our experience around this is really phenomenal and valuable in terms of standards. So as I mentioned, experience across this and ArcGIS enterprise system, I mean, entire life cycle, as I told, the produce, publish, collaborate, share, use and reuse and interconnect. I think it's important for all of us when we design or we architect the system, we should consider the standard, in every part of the life cycle, not just data storage and data sharing. It has to be part of the entire, stage of the life cycle, which is very important. So thank you so much. I thought to bring actually only these slides here and sharing a couple of our experience, around the world and in India also in a couple of large implementations. And I think thank you very much, BIS and ISO for inviting me for sharing my thoughts. Thank you so much. Thank you.
Thank you. Yeah, thank you, Vijay. That was really good. I think that the things that I pick out from your talk really was the wider effect that standards can have. So in data governance, engagement, data and technology, I think sometimes they're overlooked. But if you've got good standards in place, it means that those aspects can be easier implemented. So thank you very much. We've got 3 further speakers, so I could have asked the gentleman on the stage to step down, and we'll ask the new speakers to join us, or are we doing something different?
So I'll request Ms. Reena Garg to kindly deliver a mementos to our speakers as a token of our appreciation. अच्छे से दो. No. Then only Reena Garg and Reena Garg and Akhilesh, not me. अभी लगा. So before we proceed further, I would like to inform that all of you delegates are kindly invited to join for the networking dinner, which is today at 7 p.m. at Silver Oak Hall. So the dinner invitation is your delegate kit, but I am again inviting you for the please, because some of the delegates are leaving, so I'll just request you to please be hold and join us for the networking dinner. So Alan, over to you.
Continues. Good. Okay, for the for the final part of session 2, we've obviously got our panel session to follow this, but in session 2 we've got 3 additional presentations. So can I ask Dr. Rajendra Gaikwad to the stage, please, and PV Prashankar, and also from the BIS, Reena Garg and Dr. Akhilesh, please. Okay, we're ready to continue. Our next speaker is Dr. Rajendra Gaikwad. He he's presenting on the development of GIS standards and application cases, and he comes from the Indian Space Research Organizations. Thank you.
Thank you. Good afternoon, and those who are joining remotely, good evening and good morning. So basically, this is the title I have chosen for the presentations. Today's we are talking about the GIS and geoinformatics as a subjects. So basically, what types of data standards we are adopting at national level, and the practices we are having at the international scenario. So I was involved in this activity, so I thought of presenting these of the excuse me. So this is basically I will be covering in two sessions. Like one is standards I will be talking about, and second is the how that application has been taken care. So first part is the standard one, where basically we started the practices of the generating the standards at national level. Before going to that, we have to just revisit some of the activity what we are today's gathered here related to the geoinformatics. I just have to point out some of the points that is very, very important to understand the metadata, how or any GIS standards we are trying to adopt. So many of us, we are knowing that how this has been referring to the regions with the some of the point locations and how the data can be realized in the sense. So if you see the history of flowing this activity in this environment, like whatever the phases are there, I just want to revisit that one. When the phase one, when 1960, this has been started basically for the organization who trying to understand the processes, and it was in a deep pockets kind of thing. So it was not publicly available. Then slowly, many organization has to come together and they try to learn the processes in 1965. Second phase, we found that there are the information system, like there are the attentions at the national level that has been taken care, and the processes has been standard to the standardization process as such. 1980, that is phase three, we found that this information system, which is has come in the market point of view, how it is a marketing kind of thing, how the business sector has been evolved in that one. And this is the phase four, where I would just want to highlight that the inventions, we are talking about the various technology. Today we are talking about the AI, ML and all these things. So these are all geospatial technology has been evolved, and that we try to emphasize on that one. So today we are at today's 2023. I just want to highlight that today we are here with the BIS and ISO. These are the standard, and even OGC are there. So these are the driving force, we can say that. So basically, it gives the directions to how our standardization process in the going in the geoinformation services. Before going to this actual development, what took place, I just want to highlight some of the points on this. We have to understand how this standardization in GIS, it took place, and there are various what you call data sharing concepts we talks about last 2-3 days. There we are talking about the geospatial standards, and then there are the types of standardization like what we talked about, different types of standardization like interoperability, interchangeability, various things are there that we try to understand it. There are the standardization 5 years, like it is highlighted in here. We talked about the deploying the various technology, various activity we are doing. And there is a fourth one is the development of the GIS. That is how this concept and has been evolved in this one, where the software has been like previous speaker, we have seen the there is a software how that help us to understand this process. So these are the all activities, GIS development. Just want to put it in front of you. Now I will come to the actual how the evolvement has been taken place. So if you see the metadata elements of any development, services has the two components as such. One is your data generator, and second is the data user. So special data set, if you see, the data generated is very, very important. So how that data has been generated, and that has been reflected in the metadata as such. So this metadata standard, which provides a framework to that generator to help us to disseminate the services. And the user at the user side, we have to see that how these standards can be used for the many purposes to finding the like morning we have seen the US presentations that my phone is I'm having and carrying from somewhere. All standards are helping me in all the locations and many purposes. So how that user will get benefited, that is what I just want to highlight it. So metadata standard, basically we at our center, we started in 2003. First metadata standard was published. It was 1.0. NSDI was the focal point. And various organizations, as previous speakers talks about the FSI, and there are GSI is there, and there are NATMO and various CWC. These are the organization. These are all national bodies. They have their expertise in their sectors, and we sit together and we try to bring these national standards. So that this 2003 we started the first version, and I just correlated with the yesterday's presentation. UN FAO has started with the LULC standards in 2003. So I just want to correlate with that one. I will come to the next point also. So this is a NRIS what basically helps for the understanding the data sets in this area. The concept of NNRMS standard when was designed that time, and it was a very good objectives and visions for the understanding the data at the spatial, non-spatial concepts, and we try to how design the GIS database itself. So we adopted various software and various frameworks understanding the data, geospatial data in the national interest. So this is 2009, 2.0 has come. So again, it is correlating with FAO has came with the in 2009 ISO 191441. So you can see that as national level also we are moving in that way. That one version has come, second one where the international level like LULC standards was also going on. So parallelly, our activity was in that directions to understand the various standards. We adopted the Australia. Then there are some doubling code standard was there. These elements was very good that was described in the metadata services. So we took the help of that. These are the organizations which associated with the activity in 2.0. These are some of the elements. Most of the things are there published in 2009, and there are various data sets like 28 elements was designed. Out of that, 9 was mandatory, and some of them was optional. So that was the idea behind that. Many of the organization may not having that type of data, so we can have the provision to give the platform to the end users so that their applications can be accommodated at the spatial repository. So that was the idea we started with it. This is the 2016, what we presented in 2009 as a NSDI 2.0. It has been converted as a BIS as came in activity of this Indian standards, and it has published in 2016 with the IS 16439. And again, we adopted same standards of the actually published, and there was some revision has been taken as far as the wherever the technology has been changed accordingly. So currently, this is in the present mode, like a draft mode is ready. So 2013, we now coming with the new ideas of the UML diagrams and all these things, which is all ISO standards are following. So idea is that we try to understand the new concepts are there for the bringing the database to bringing the geospatial data standards in for the nation. So this is what about all activity we did it. And some of the things we talked last 2 days, we talked about the 10, this is one paper, like 10 by 10 possible data formats are there and they want to interact with. So many organizations are there and they want to do the business of transferring interoperability, many things are there. So we have our geo services at ISRO and many organizations are associated with it. So we did this activity and we are ready with the geospatial services as such. And if you see this now, National Geo Policy has come, so it should be what you call for the user purpose, like citizen centric. So 2017, it was presented like we should come with the ideas of let us give it to the public so that it can be benefited for the all the. This is some of the references from the OGC to understand how this activity has been taken care. Anyway, today's morning we had this all presentations of the fair. So I am not going to repeat it, but I just want to say that whatever the findable, accessible, and what are the advantage of this fair, at our center, we have the portals of geospatial at ISRO. Most of these technology, this whatever the advantage of fair, we have adopted and we already ready with the solutions. Anyway, I am not going in that one, why it is important, all this thing. So this is when 2009 geospatial world has published our and what is this importance of this publication? It gives visibility to the many users who are not aware about the standardization process. Like NSDI is doing the workshop and all this activity, and there also many organizations may get benefited or may not be. So that was the issue. And this was the repository platform. We try to put it all the standards for the NSDI. As I said of the NSDI workshop, we try to train the people and we conduct a workshop accordingly. And there some of the development which took place for the disseminations of this metadata services has been demonstrated. If you see the last one, this is the tool we developed that time, and already data was there, and we try to map the data with this tool. And this tool is directly automatically generate all NSDI metadata standards. These are layout of that tool which sits in between, and as we have seen that many spatial data available with the n number of agencies, those who stakeholders, they can be easily use these tools, and that was given its XML services. This is the interface of that tool. So that was designed and developed long back. This is the reflections of that all metadata on the national portals. I will come to the second point. If time permits, I will try to make it fast. This is applications. First is when we do any type of activity for the application development, there are different types of steps are there. Like one ladder is talking about the coordinates, second ladder, I'm just trying to highlight it in such a way that when we want to put geospatial services, we have to sit together and bring all this to bring that is the actual requirement for the services and data models. This is the after development of this metadata standard, this is the one portal of ISRO. This is the National Database for Emergency Management portal. So it is basically a geo portal to disseminate space-based inputs along with services of forecasting organizations. And if you see on the this front page, recently I captured on 2nd December, there were some warnings and current disaster related issues. So it is dynamically, actively taking its, why I just want to showcase this one, because of this only. So this portal is now following all the NSDI standards, what was published, and now it is ready with the all database. So that is the activity which is happening at different portals at national level. So this is again NSDI format, what they try to put it in this portal itself. This is another portal, NATMO is there. This is a National Atlas and Thematic Mapping Organization, which is the collaborative agencies with all these activities. They also have their interface, and they also adopted these standards at their web services. We have the different types of stakeholders, like national bodies are there. There is a metadata related to the issues. They try to, like, Kerala state remote sensing is there. They have adopted this one. Where I am involved in at our center, we have this Vedas is there. Is the basically visualization of Earth observation data and archival system. This is one of the portal which has the various applications. It was listed on the application site. You can visit this portal. Basically, idea is that we have the all remote sensing data in a large number of disciplines, which includes agriculture, land use, photogrammetry, forestry, and environment, coastal, marine resources, hydrological studies, and various urban and infrastructure, cryosphere, spatial data sets. These are all atmospheric and ocean sciences, early warning, and we have the planetary sciences, etc. All these are hosted in this portal. So idea is that we try to put it many of the applications at one platform. And now this is a research purpose. This portal can be utilized. National level also, this has the visibility. Now various activities has been taken care by the ministries, and that was showcased in this portal itself. This is one of the metadata which this portal is also following. So this is an SDI format. So interesting thing is, yesterday we discussed about how this metadata or any API can be used. So this portal is now using the REST API for the Vedas layers metadata. Whatever the data is showcased in this portal, it is giving now API, REST APIs are there. So you can get the metadata out of that one. So that is very interesting part of one of the services we can give it in this way. This is fully automated part of this is one of the data sources where we try to put it Sentinel 1A and B SAR data on a Vedas portal. You can see the entire India is now covered in this one. So it is a very interesting web services. You can have visit of this one. And this is again flood monitoring services are there. You can have the flood monitoring of the various parts of the country, and that can be utilized for the any decision making processes. This is very interesting applications on this application portal. Is a solar calculator. We have the Android app and we have the services. Basically, at any locations in India, we can have the get the solar potential, how much power can be generated. That will be possible through these applications. I'll just try to hurriedly complete this one. Anyway, these are some applications. You can visit this one. This is another portal of ISRO, Bhuvan, where we try to give the various data services to the end users, and all satellite data has been showcased, and we give the services to the various ministries also. So basically, this portal is also following the metadata standards. So that was the idea to put these slides. We have the state stakeholder like Kerala State Remote Sensing. They are also following. Jharkhand State Council, GeoHub is there. They are also following. Maharashtra Remote Sensing. So these are all state agency who are involved in this activity. They all following all these NSDI metadata standards. So that was the achievement what BIS is trying to put it, their efforts to standardize the geospatial data services. So anyway, these are some applications at my center related to the meteorological and oceanography. You see these are the open data is available. There are 3 categories: land, air, and we have the ocean. So various data sets are there. It's openly available for the research purposes, and anybody can visit this one. So this portal also, we have the data standards. Like we are trying to put entire data in the showcasing in this way. So anyway, I'll just go. Now time is very less. So this is just question to all. We have to ask ourselves and try to understand how this standard, like morning we have see what for and why I have to bother about the GIS standards that we saw in the morning presentation. So anyway, these are policies we talked about, and we have to comply 100% all over in world, so that we can have we can say, yes, I am complying with all standards available. That was the idea. And with this, I thank you. So together to lead, that is the message I just want to give. If we sit together and bring the all standards in a one showcase. So thank you, sir. Yeah. Thank you.
Okay, thank you very much. That was really useful, a really interesting talk. The things I picked out of it really was that you started on a metadata journey to create a metadata standard, and it led to I'm guessing much easier development of the applications that you showed later on. So I think that's another lesson for today, really, is that if you do go down that standards route, it can lead to so many different things. We've had it from Regendra and also from VJ previously. It does help to cover a lot of different aspects of geospatial data management, including things like governance. So yeah, that was fantastic. Okay, we've got two more speakers to sit before we have a break, and this is the one I've been looking forward to actually. As being a part of a national mapping agency myself, we've got PV Rajashekar from the Survey of India to talk about geospatial standards in the Survey of India.
Good afternoon. I thank the organizers, ISO and BAS for giving me this opportunity. I'm not actually planning to talk about the standards which are being developed by Survey of India. I think that is being done in collaboration with BAS, and that may be part of the presentations of BAS. Primarily, I am just focusing on the National Geospatial Policy 2022, and there are the aspects on which we need to pay attention, especially those who are involved in the geospatial data creation in India. All of you have already been introduced about the geospatial policy in 2022, announced in December 2022, and some of the aspects have already been discussed. And one of the main aspect of mandate of geospatial data policy has been that of making the geospatial data created as part of making use of the public fund as a common good, giving the right to every citizen of India to have right to access the data and then derive economic benefit out of it. So, which means the kind of demand on geospatial data is set to increase considerably, and also the expectation from the producers of geospatial data to meet the standard also is going to be increased exponentially. So this is one of the aspects. And the other mandate from the National Geospatial Policy has been that many of the fundamental data sets which Survey of India as the national mapping organization has been creating and disseminating, has been now distributed to various other nodal government organizations which are working in the respective domain, which means the responsibility now onwards to create geospatial data of roads would be to the departments which are dealing with roads, and the railways will be with the department dealing with railways, and water hydrography would be that of the departments dealing with water. So you listened from the previous speaker that how the hierarchy of the government of India and the other tiers of government is organized, and from that we have actually realized that it is not that the government at the center, with the government of the organization coming under government of India, which would be generating this data directly. Instead, this would they would be depending on the departments which are reporting to them at the lower level of government, and then those are the agencies which would be now generating this spatial data. What does this mean? All of these days, it is the trained geospatial professionals who have been generating these data as a primary responsibility under the National Mapping Organization and other various agencies which has been traditionally involved in the creation of the geospatial data. Whereas what is now going to happen is that the users themselves becoming the generator of their data. They would do this. So the data collection in those domains which have been now given to those nodal agencies would actually get generated as part of the business executing the business processes of those organizations. This has a lot of good advantages in the sense that now the data would be conceptualized and extracted by those people who understand those geographical phenomena better than those who are working in the national mapping organizations. Whereas at the same time, to ensure that this data is consistently collected regularly collected in a consistent manner, we need to ensure that we encapsulate the entire complexity of collecting geospatial database and then make it easier for us to scale up these operations of collection of geospatial data by the domain experts, but not so well trained in geospatial data collection. Whereas, if at all we need to ensure that this becomes a reality and it takes place on a regular basis in a consistent manner, then we need to ensure that the more than the metadata what we prepare, we need to focus on their business requirement, business processes, and the use cases, and then generate more and more of their application schema, and then ensure that they actually do their business process and a collection of geospatial data in a controlled manner through a kind of a workflow process, accessing the data centrally by all the organizations which are dispersed all over India. Unless and until that is done, we can never be sure that data gets collected and stored in a systematic manner. We all know by now that if the data gets collected in a systematic manner as per whatever schema, as long as we know what is the schema and we document it and publish it, we will be able to map this data from one schema to another schema, and we will be able to seamlessly access it. But unless and until we ensure that there is one-to-one correspondence between the metadata what we project and the underlying database is consistently for the extent for which the metadata has been created and the temporal interval for which the metadata has been created has been in fact collected in strictly as per the schema. There is no way the metadata and all other mapping tools what we generate would work as per the expected form. So that is why I just wanted to highlight this, that we in Survey of India have undergone this transformation from the analog to the digital, and we have had bitter experiences of making a whole lot of mistakes in the process of changing over from the analog to the digital by way of actually starting with one application schema and ending up creating multiple application schema, not for without valid reasons, with very valid reason of meeting the requirements, varying requirements of different situations where this data is being collected, and then finally ending up in a kind of a database which does not actually match with any of the metadata in a consistent form. And I see when you look back, the entire data collection in Survey of India in those days was being monitored and controlled by those who were veterans of geospatial technologies. They were masters of photogrammetry, geodesy, cartography, you name it, everything. But still, that ended up in creating such a mess, and we took a lot of resources and effort for us to finally come out of it. And now there is no reason to believe that the newly introduced organizations would not make the same mistake and end up creating the very kind of confusion and the mess what ended up creating in initial stages and then delaying the whole process. Now that the data, there is a high demand for the data, and applications, once it is getting generated, and if the metadata gets created, if the data collection process was not managed in a controlled and a systematic manner, ensuring that there is systematic adherence to the schema, there is no way we will be able to use it. I wanted to give this opportunity to bring everyone's attention who are involved in preparing standards and managing the transition of organization mandated by the geospatial policy in India to pay at most to focus on this and ensure that application schemas meeting the requirements of those organizations, mainly endangered organizations which are given the responsibility of giving the generating spatial data has been made as fast as possible, where this time the essence and then made available and it is disseminated in a complete so that we have a better chance of not committing the mistake. The national mapping organization, including me, ended up committing in the earlier stage of the digital transformation we have undergone. So this is a major aspect along with all other the standards, whatever we are just now paying maximum attention on. So if this message is conveyed to all of you, I think I have done the job. Thank you for patiently listening to me. Thank you.
Thank you very much. That was really useful, really useful summary of the policy work you're doing with standards at the Survey of India, and potentially the journey you've had between analog and digitalization, in which you've introduced standards to help you in that process. So it just highlights another use of standards, really, when you're making a sort of business transition from one position to the other, whatever that may be. Standards can also be helpful. Okay, before we adjourn for a break, I think it's fitting that the last presentation in section 2 is from our hosts here, the BIS. So for this talk, we've actually got 2 speakers, Reena Garg and Dr. Ashikawa from ISRO.
Okay, I'll be okay. Good afternoon, everyone present in the hall and the virtual participants. So I'll be making a presentation giving an overview of BIS and its activities towards standardization in the field of geospatial information. I'll be very brief, 5 minutes for me and 10 minutes for the speaker next to me, Dr. Akhileshwar from ISRO. So he'll be just telling about a part of the project we have undertaken. So I'll be telling you like subsequently in my slides. So BIS, by now all of you know that it's a national standard body of India, and it was established in 1947, and now there was a sorry, in 1986 there was a BIS Act which has been revised in year 2016, and it's a act passed by Government of India through which it has been designated as National Standard Body of India. And core activity of BIS is not only standard formulation, but there are other activities which are carried out by BIS, like conformity assessment for products, self-declaration of conformity, hallmarking for precious jewelries and precious stones, and system certification, then testing and training. So all these activities are carried out by BIS. And just to give you an idea, like BIS develops standards in 16 sectors through 16 division councils. And under these division councils, there are 350 technical committees, which we call sectional committees, assisted by more than 22,000 experts who are the members of these committees. So out of these 16 division councils, there is a division council, electronic and IT. And so these are other divisions listed over here. So under electronics and IT, we have 35 technical committees. And one of the technical committees is LITD 22, which is geospatial information. So these technical committees comprises of various stakeholders, like the all kinds of stakeholders, from the consumer groups, the industry association, and the manufacturers, regulators, R&D organization, academia. They are the part of these technical committees of BIS. And how we prepare standards in these technical committees, the process is very much similar to the process being followed at ISO IEC. So it's a two-stage process. Like firstly, there is, after we receive the proposal, it is approved by the committee and then discussed narrowly within the committee. And then once the committee approves it, it goes for a wider circulation for public comments, and all the documents are hosted on BIS website for public comments. So it is very much similar to, I don't need to go into the detail of this, which it is a very transparent and very dynamic process, and just similar to what we do at ISO and IEC. So we are closely following up these committees from ISO, IEC, JTC1, IEC, and ISO. And BIS is BIS in India represents at all these forums, and is the founder member of ISO and IEC. And BIS through these committee members, the technical committees of BIS, the members from these represent India at ISO and IEC. If somebody from India has to represent an ISO and IEC committees, so that person has to be the member of our National Mirror Committee. So now coming to LITD 22, which is responsible for geospatial information standards. The mandate is to produce national standards and also act as the mirror committee for ISO TC 211. So the composition, just to give you an idea, like the BIS officers are the member secretary, and they provide a platform to the stakeholders in the country to prepare standards. So Ashish, with whom you have been interacting, is the member secretary of this committee, and we have almost all the relevant stakeholders in the country who are represented on this committee. The chair from DST and AGI, there is an institute called BISEC, Central Groundwater Board, Central Pollution Control Board, Central Water Commission, ESRI India, Forest Survey of India, and from the academia, we have various IITs on our committee, and ISRO is a member, InSpace is a member. Then from the ministries, various ministries are the member of this committee. And the Survey of India is of course there. Then OGC is also there on our committee. So NSDI and we have, you can see that we have on board all the relevant stakeholders who should be there in the, who are relevant for this work. And so committee members, these are about 30 organizations who are listed, plus there are panels and working groups under this committee where there are another members from these organizations. They are also represented, and some in personal capacity as well, some individual experts who are working for development of standards in these areas. So at national level, we have so far, we have really picked up now for this particular committee after we have this policy has been announced. So our plan is to go very aggressively now, is to very aggressively and actively start the process of standardization in this field. So the numbers are not very impressive here, but we are working hard to align ourselves with the ISO standards and examine each and every ISO standards for the suitability of adoption in Indian conditions. So the standards, 60 out of these 16, 14 have been the adoption of ISO standards. And one of the important standard is the metadata standard, which my previous speakers, Mr. Rajendra Gaikwad ji, has just informed. The NSDI standard, which was adopted as 16349. It is based on ISO 19115, and we are in the process of revising this standard in line with the revision of the ISO 19115. So we at present 12 standards are under process of development, and you have already heard about this data content standards from the previous, from one of the speakers, whatever work we are doing, and we'll transform all that in the form of Indian standards with respect to soil, geology, and forestry. And then we are working on cadastral data content for geospatial information, we are in the process of revising 16439, and we have taken up these two very important standards on airborne LiDAR and NAVIC receivers. So now I just hand it over to my next speaker, Mr. Akhilesh from Dr. Akhileshwar from ISRO, to just give an overview like what this standard is all about, and like we intend to take it up further with ISO when we are like we feel confident to submit it to ISO. This is TC 211. So Dr. Akhileshwar will just be taking you through the content of this standard.
Thank you, ma'am. So good afternoon, everyone. I'm Akhilesh. I'm from the Satellite Navigation Program Office of ISRO. So in the morning presentation, Mr. Allen has spoken about the importance of data quality. And one of the parameters that he was mentioned was position accuracy. So this standard is generally aimed at meeting that and representing that in the process of data collection. And Mr. Rajshekhar has also mentioned that they're opening the data collection to different organizations apart from multiple organizations, apart from solely depending on Survey of India. So from that perspective, we felt that having a standard on the data quality per se, especially related to positioning, is important. So this is the basis for working on this particular standard. So before we go into the standard itself, I would just want to briefly introduce NAVIC. So NAVIC stands for Navigation with Indian Constellation. It's an independent regional navigation satellite system that is developed by ISRO for India. So it essentially covers the Indian subcontinent and the surrounding regions in its coverage. It is comprised of a 7-satellite constellation, and we are in the process of upgrading the satellites. So it provides 2 position, navigation, and timing services, which is the standard positioning service, which is meant for civilian use, and the restricted service, which is meant for military use. So we are also planning to expand the coverage area of NAVIC to include more regions in the service area. So coming to the receiver standards per se, we are seeing increasing adoption of GNSS, or for that purpose NAVIC equipment in India across different sectors. And some of the sectors have relevant sector-specific standards. And these standards are published under different organizations, and they are specific to a particular area of application. But there is no generic standard per se which can verify if an equipment is conforming to the support claimed for the particular GNSS per se. In this case, NAVIC. So we wanted to work on a particular standard which can verify if a receiver is compatible with support for NAVIC signals. So we have gone through some of the ISO standards that are there, which are relevant to GNSS per se. So these are a list of some of the standards that are there. But what we felt that they're more from a perspective of defining the service quality of a GNSS system rather than the user equipment that is used to collect data using the GNSS signals. We have one standard that is there on a classification of GNSS receivers, but that particular standard does not have any reference to the performance of the receiver per se. So we've gone through some of the sector-specific standards that are present for the GNSS equipment. There are multiple standards in the transportation sector. There are certain standards in the communication sector released by 3GPP. Then there are standards for high accuracy applications, the RTCM under RTCM. Then there are certain standards for data exchange. And there's also a standard for marine navigation through IEC TC80 under IMO. However, all of these are, again, as I mentioned earlier, these are application-specific and sector-specific standards. In addition, there's an International Committee on GNSS, which is part of United Nations Office for Outer Space Affairs. And these is basically a collaboration between different nations who are interested in GNSS activities and who own GNSS systems of their own. So under that particular committee, there is a IGMA task force, which is International GNSS Monitoring and Assessment Task Force, And that task force is working on certain standardizing certain aspects of GNSS functionality. Some of the examples are given here. Again, these are all specific to a particular development technique or a service offered, or again, they're specific to certain logging and related aspects. But again, as I mentioned earlier, there is no specific standard for a performance of a user equipment that is used in the field for using the GNSS signals. So there is one existing standard on GNSS receiver performance. It is a European ETSS standard, EN 303413. But this standard is again only supports the 4 global constellations, which are GPS from USA, GLONASS from Russia, Galileo from EU, and BDS from China. However, there is no support for the regional constellations, which are NAVIC in India and QZSS from Japan. In addition, I'm aware that South Korea is also working on their own positioning system. And as such, there is no such support for their positioning system also in this particular standard. Moreover, this standard is only limited to 2 frequencies, the L-band frequencies, and there's no support for S-band signals where NAVIC has signals in the S-band. And the Korean system is also planning to introduce signals in the S-band. So considering all these, we felt that we need a generic standard for receiver performance, especially for NAVIC. And we felt that it is required because we want to provide a sort of a common denominator to identify whether a particular equipment is supporting NAVIC or not. And in order to, it is also aimed at simplifying any further work that an application-specific standards body wants to conduct in generating an application-specific standard, wherein they can just refer to this generic standard as a minimum requirement, and then based on that, they can improve the certain specifications which are pertaining to, which are especially important for that particular application and which require more stringent specifications compared to generic standard. So that is the aim. And then it obviously aimed at improving the adoption of NAVIC in the Indian sectors market. So this is the general idea behind which we went forward with generating this standard. And the LID 22 committee of BIS, we have officially got a recommendation for establishing a panel for working on this particular standard. So the panel 5 on NAVIC receivers was constituted, which is led by Dr. Manish from ISRO. And we have a different members from academia, industry, and government organizations who are helping us in developing this particular standard. And we are currently working on the preparing the draft. And once we are ready with it, we'll be circulating it for the comments and recommendations from industry and academia. And once we are ready with this standard, we plan to propose a work item in the ISO TC 211 in order to evolve it the same into a possible global standard. Thank you.
Thank you very much for both speakers there from the BIS. I mean, one thing that I did know, actually, you've got 2,500 standard makers within BIS, so that's quite something. So you won't be short of people to be able to edit and put standards together. That's fantastic. And I did the GNSS thing. I think you're right. I think you're hitting on something with the quality issue. I think a lot of people made the assumption that the signal comes from the satellite, it's received at the Earth, it's technology, it must be correct, sort of thing, but that's not necessarily the case. It bounces through the atmosphere and does all sorts. So that's really that's really useful. So I think we've come to the end of session 2. So I think we've got some presentations to make. Thank you.
Thank you, Alan. I take this opportunity to invite Mr. Ashish Tiwari, Scientist D, LITD, and also the Member Secretary of LITD 22 to please present mementos to our distinguished speakers. Sir, if you could please, Mr. Rajendra Gaikwad, Space Application Center, ISRO. Ashish? Mr. PV Rajshekhar, Survey of India. Ms. Reena Garg, Head Electronics Department, BIS. Sri Akhileshwar from ISRO. Thank you so much, sir. So with this, we come to the end of the second technical session. I would request everybody to give a big round of applause to Alan for conducting these sessions so nicely. Thank you, Alan. Please join us for the tea. Our next session will begin at 4:30.